Hello everyone, it's me Tabo and welcome to another episode of Coding for Superheroes. So today we're going to be creating this cool animation here. This is by far one of my favorite animations. I think it looks pretty cool. It just looks like something out of this world. It just looks so alive, with the way that it moves. So today this is what we're going to be creating. So let's just jump right into it and let me show you how it's done. Okay, so as usual, I have my basic code here. So this is just a basic scene. I've got a renderer, I've got a perspective camera, I've got our scene. I've set the scene background to this color. We've got a hemisphere light. So these are the color settings for it. And then we've added that to our scene. This is just to manage the window sizing. Our camera is positioned at 5 on the Z-axis, and we've created an orbit controller. The rest is for the animation. So the first thing we're going to do is create a sphere geometry. And then from there we'll create a mesh called sphere. We'll be using the geometry, and then we're gonna use a mesh standard material, and we're gonna use these settings over here. After that, we're gonna scale it to 0.9 on all axes, and then we'll add it to our scene. Okay, then after that, this is I just want to say this is similar to the last tutorial that I created. Basically the process is similar. So we're going to be using normals and vertice position, and this is where we're going to then create blocks. Okay, so once again we're going to create a variable called normals and one called position. So this is for our normals and this is for our vertice position. Then after that we're going to load a texture, which is what we're going to use for our environment map. Okay, so we're going to use that on our sphere. So we'll set the mapping to 3.equirectangular reflection mapping, and then we'll set it to the sRGB color space. Then after that we'll just then map it to our material like so. And next we create a box geometry, and we're going to give it a mesh physical material, and we're going to use these settings over here. Then next up we create two matrix 4 variables. Okay, so we're going to be using these to change the rotation and the translation. Okay, once again I need to fix this little error over here, angle to degree. This is like a function that I created myself, but we'll be using a math utils. So we'll say deg to rad, and then we'll say 90 degrees. Okay, so basically we're going to rotate it by 90 degrees on the x-axis, and then we'll make a translation on the z-axis to 0.5. Then once we're done, then we're gonna then apply the matrix to our box geometry. Then we'll create a mesh out of it, and these will be using the box mat 2, which is this mesh physical material. Then we'll set the scale to 1.5 on x and y, and then we'll set it to 0.2 on the z-axis. Next we create a box group, which is a new 3.group. Then we create 3 other variables: a normal position, which will be a vector 3 vertex position, which will be a vector 3 object, and then dummy obj, which will be a object 3D. Then we create an array called spikes. Okay, but it's not really spikes, it's actually blocks. It's just, I think it's a name that I used before, but I actually did not change the name of it. But this is where our animated blocks will be pushed. Okay, so next we create a for loop. So we go through our position variable. Then we're gonna basically access the normal direction and the vertex position, and then we're gonna assign that. We're gonna add that to our normal pos using vertex pos, and then after that we take that position and we copy it onto our dummy obj, and then we look at the direction of the normal position. Then we will scale our dummy obj to a box 2 scale, and then we will divide that by scalar. We're going to use 15 as the number to divide by. After that we create a clone of our box 2 mesh. We'll call it new box. We'll update our matrix on our dummy obj, and then after that we'll apply the matrix to our cloned box mesh, which is new box. And then after that we'll push it into our spikes array and then add it to our box. And just underneath here we're just gonna then add our box group to the scene. Okay, after that I'm gonna create some variables. I'll create a clock variable, which will be derived from the 3.clock. I'll create another one called time and one called offset. Now inside our render function, we're going to set our time to clock.getElapsed time, and then we're going to multiply that by 2. Then over here we're going to set our offset to 0, and then we're just gonna increment it inside our for loop. And so inside of here, we're gonna create some variation in the animation. We're gonna use a modulus of 2. So depending on the value, then it will either scale the x-axis or the y-axis of the block. So this is just to create some variation, and the same thing is happening with the rotation. So it will either rotate the x or the y axis of our block. Then we'll use this also to create an offset on our animation. So this will be running inside of our render function, and once we're done with that, then we're gonna rotate our box group in the y and x axis. We're gonna use just different values also, once again, to kind of create a dynamic animation. So yeah, that's about it. So let's check out what that looks like. So we're gonna run our server and then have a look. Okay, there we go. So here's our animation. Looks like everything is looking proper, and this is how it's supposed to be. So this is a pretty cool effect, I would say, and it's not really all that complicated to create it. One thing that I like about all of this is what you can do with math functions. I think they're pretty cool for creating really dynamic animations. It just has the ability to like bring things to life instead of animating like manually. You could never create this manually. It's pretty much impossible, but with math functions you can just really create unique looking stuff. And the other thing is that you don't always have to complicate things. You don't need complex equations or even like a lot of knowledge of like, for instance, with shaders are pretty complex, and they make for great graphics. Like, it's definitely recommended that you learn them. But one thing that I realized with animation is that it's basically knowing how to trick the eye. It doesn't always have to be the most complex code or formulas. You just have to really understand the principles of animation, that what you're actually doing is just you're tricking the eye. And to trick the eye, you just have to understand how we receive information, and you just use movement, you use lighting, simple things to actually really create cool looking animations or effects. So it doesn't always have to be like really complex stuff, because sometimes you can overcomplicate things with how we think things should be done and whatnot. But anyway, that was just my 2 cents worth. But yeah, overall I think we're done here. So I hope you enjoyed this, and if you've watched till this far, then you are sure to subscribe, like the video, share the video if you think that this is valuable. Share the information, and hit that notification bell so that you can always be notified when the next tutorial is coming. So yeah, let me just say love and peace. I'm out.